Hello.
Hello.
Hi.
Hi.
Go ahead and get started with the interview here.
Mhm.
Looks like we're doing data structures algorithms.
Yeah, that's right.
Okay, so it's a typical interview for
Mhm.
most tech companies. Do you have any interviews set up with any companies?
Not yet, not yet.
Okay. When are you planning to set interviews up?
So I plan to start uh, contacting recruiters probably by the end of this month.
Okay. Cool. What level and role are you interviewing for?
Probably I think the level above the entry level because I have experience in um, other like tech areas, but not like
Mhm.
software engineering. So
Oh, I see. What's your
yeah,
current role?
yeah, I'm a data scientist.
I see. Okay. Um, let's go ahead and get started with the problem then. Are you on the code bunk?
Yeah, yeah, I
Okay.
open it. Yeah, do you want me to share the screen or?
Yes, if it's possible.
Yeah, cool.
Select the language of your choice at the top left corner.
Yeah, I already did. It's Python 3.
Okay. And I see you already hit the run button to see that the
Yeah,
uh, thing
yeah,
is working. Cool.
yeah. It's okay. Yeah.
So I'm going to spend a little bit of time talking about the problem. Then afterwards, if you have any questions, please let me know after. And then if not, let me know what your thought process is, your initial thought process is, and how you can solve this problem. So have you played chess before?
Uh, I know the rules, but
Okay.
I'm not a player. So yeah.
Okay. Do you know what the knight is? The knight piece in chess is?
Yeah, yeah. I
Okay.
know the rule.
So
Yeah.
okay, so the knight moves in an L shape,
Hmm.
and it moves two spaces, and it jumps. One jump is, and this should just be a refresher. Two spaces horizontal, one space vertical, or one space horizontal, two spaces vertical.
Hmm.
And it can't go out of bounds. It can't wrap around. It's just within the board, and that's all it can do.
Hmm. Hmm.
So that's the knight piece. And here is a number pad. So the number pad is the same thing that you get in the phone, on your phone when you dial a number. You select the buttons, the numbers that will make up a phone number in the order from left to right, right? And that's how
Hmm.
you like dial a number on the phone. So with these two components, I want to place the knight on the number pad, and then given S, which is the starting digit
Hmm.
from 0 to 9, and the number of jumps, I want to return the total possible numbers that can be generated by having the knight jump starting from S. N will be the name of number of jumps. Actually, let me do this. So that, okay, S is starting digit, N is number of jumps.
So return total possible numbers that can be generated by having the knight jump starting from S. Okay.
Yes, so let's say my S was equal to 6.
Hmm.
My N was equal to 1.
Hmm.
So we put the knight here, which
Hmm.
is on 6,
Hmm.
and we can have it jump remember, 2 spaces horizontal, 1 space vertical, 1 space horizontal, 2 spaces vertical. So we jump here, 2 spaces horizontal, 1 space vertical, so the 7. Or we could go 1 space horizontal, 2 spaces vertical here, or 2 spaces horizontal, 1 space vertical here. So in this case, we return 3 because we have 6, 7, 6, 1, and 6, 0.
Okay.
That's all.
So so that means we cannot okay, so only one jump. Okay.
In this case, we have 1 jump, yes.
Yeah. So is that possible to show me an example with like two jumps?
Sure. Let's change n to 2. So in this case, we jump, let's do 6, 7. So from 6, we can jump to 7. That's 1 jump. Second jump, we can jump to 2 or 6. So this would be 6, 7, 6, 6, 7, 2. Then 6, 1, we can jump to 6, 1, 8, 6, 1, 6. Anywhere else we can jump to? Probably not. 6, 0. We can go from 0 to 4. And then we can also go from 0 back to 6. And go anywhere else? Probably not. So in this case, we return 6.
Okay, I see. Okay, that's the total number of the. Yeah, I understand the problem. So the numbers. So okay, so all the possible moves. Okay. Yeah, my thought will be first. I think it's kind of like tree problem to me. So if we treat every number as a node, and the so possible next steps will be the like child node of those like parent node. So let's say for 6. So there are 3 possibilities, like 0, 1, 7, and for the number 0, there are only 2 possible. So it's 4, 6. And by doing that, and also we can keep it's like a DFS problem. So we start from like n is the length of the not length, but n is the height of the tree. So then we are counting how many like leaves we have with like a certain node as a starting point. Am I making sense?
Yeah, that makes sense. How do we define the number of branches per leaf?
We can start in
node. Sorry.
Okay. Yeah, go ahead.
So how do we know how many children per node?
How many children per node we have is, I think it's predefined by the looks like it's predefined by number pad. And so for each node, so for certain number, we always have like the fixed number of possible like destinations we can go, right?
Okay.
So we can use for example, a hash map to store the possible next move.
Okay.
Yeah.
Sounds good.
Yeah.
What's our time complexity?
The time complexity is, let me see. So for n moves, so that's the height of the tree is let me see. So look, it's like 3. It looks like to me it's like a exponential, right? I'm not sure. I'm thinking of, because for each, let's say for the level 1, you have. Can I write it here? So
yeah, you can write it here.
yeah, I can write it here. So yeah, I'll start from here. Okay. So let's say for the level 0, we have for the height equals 1. So we have let's say we start from 6. So we have 3 possibilities, and from height 2 for 3 child node, each have depend on the numbers it has. For this case, I think I only have like each have 2. So it's like so either it's like 2 to the n, or let's say 6 height n. So it's 2 to the n or 3 to the n. I think it's between those two. I think looks like. Yeah.
Okay.
That sounds right to you, or am I off? Okay.
And space complexity?
The space complexity, I think it's it depends if we want to store the. Okay, looks like we only need to output the number, right?
Yes, we only want the number.
Yeah. So space complexity basically is how long is the recursive call stack. So I think it's a space is like a n. So that's the maximum length one we will go to the end of, like what's like the length of the number of edges we need to go through if we want to reach certain leaf.
Okay.
Yeah, and for the result, since we only need to just keep adding the numbers.
Okay.
Does that sound right to you? Or?
Yeah, sounds right to me.
Okay. So you think I can start the implementation, or we can go? We need to go through more examples, or?
If you want, if you think there's a better way, or if you need more examples, we can do that. Or if you think you're ready for the implementation, we can do that also.
Yeah, I can do the. Yeah, I'm not sure if the time complexity is the optimal solution you are looking for, or you think still room to improve, or?
There's definitely room to improve here, but if you can't think of one at the moment, that's fine. We can do this one, or if you want to spend some time investigating a more optimal solution, you can do that as well. What makes you think that? Why do you think that this can be done in a more optimal time?
Because this one looks to me, I think it's kind of because for the each. So actually, starting from like the each position, actually, if we know the n, so let's say we can separate it to a smaller problem. It's like a Fibonacci problem or this kind of problem. Actually, we can separate them into like a smaller problem instead of like sub problems. So let's say for the case of n equals 2, actually is once we know the starting point, and I cannot write down. So actually, let's say s, so Sn. So for the problem 6, 2, right? So actually is if we can add like 3, we can make it like 3 sub problems. It's like 7, 7, 1, 1, 1, and 0, 1. So by doing this, actually, it's kind of so because we are repeating some sub-problems like many times in the calculating of the total numbers by using DFS. So we can convert, looks like we can convert this to a dynamic program problem.
Okay. What would be the time complexity of doing it this way?
So doing this way, probably it's the time probably it's 3n.
Okay. Why 3n?
Yes, 3 like I said, not 3. I think it's just O. I think it's just On. Looks like just On.
Okay. And then what about for space?
The space. So let's say for each step, we can. So in this way, we need to. So we have like a 9-digit. And for dynamic program table, so we have the 9-digit, and for each digit we for each step we just keep one rest. But it's 9. Like it's kind of also it's like On, and ideally I think we even can like optimize this. So space. Let's say I just write down. So time is On, space is On. So actually, in certain cases, we can even simplify this space to O1, I think. But that will make the kind of coding. The code is kind of a little bit complex. So if I'll start from On, but later I can try to optimize it to O1 for the space. Because we only need like a list of 9 elements to store the numbers. Yeah.
Okay.
Yeah.
Sounds good.
Okay. So is this does this sound right to you for the dynamic program idea?
Yeah, it makes sense.
And is that the kind of the optimal solution you think? Or
can you think of one that's more optimal?
I think On probably that's the. Or we can use. I'm not sure if there's some mathematical way we can directly get the number from the probably there's a mathematical way to direct get that, but I'm not sure. I cannot think of a mathematical way.
Okay.
Yeah.
That's fine.
Yeah.
So do you think that you can get started on an implementation for your current thought process?
Yeah. I can try to start to write down. So one question. So since we have IDE, so while I'm coding, can I just run some? I mean, or I needed to finish the coding, so the whole parts. Then I can start like doing some like intermediate, like preliminary running, all those kind of things.
It's a good question. Up to you.
Okay.
You can do whatever makes you more comfortable.
Okay, thanks. So so while I'm coding, do you want me to like think out loud? Think loudly? Okay, yeah. Yeah. First, I'll define like a dynamic programming array. So the array is so the length will be the so it's like a it's like 2D array. It's a 2D array, and so the S will be for 2D array, it's we can call it jumps equals 0 multiplied by yeah, 0 multiplied by 9 and sorry, 10. Okay, 10 digit, and for range. Range. Yeah, probably just use +1 to make it simple. Okay. So let's do the array. So the height is n+1. And the width is 10. And also we need I call the jump dictionary. That's basically all the possible move we can start from each. I think that should be the should be it's instead of next move. I will store the previous move basically from which numbers they can reach current number. So for the 0, I think, sorry, 0, it can be reached by, so 0 can be reached by 4 and 6. 1 can be reached by 6 and 8. 2 can be reached by 7 and 9. 3, 4, 5, 6, 8, 9. By 4 and 9. Sorry. All right. So we can reach by 4 and 8. 4 can reach it by 0, 3, 9, and 5 can reach it by 5 can be, so based on rule, 5 cannot be reached by anyone, right? Is that right?
Yes, that's right.
Okay, if you start from 5, it's okay, cannot reach by anyone. Okay. Okay. So basically this is kind of edge case. So so 6 can be reached by 0, 1, 7, and 8 can be reached by 1 and 3. So 9 can be reached by 9 can be reached by 4 and 2. Yeah, looks like the only special case is 4 and 6. And yeah, let me double check if it's right. Okay. So I'll simply add some. So one question for some corner case, if n equals 0, we just output 0, right?
Equals 0, that means you don't jump at all.
Yeah, so we output 0, right?
Let's say 1, because 0 jumps means you stay on the same place as when you start.
Oh,
So
okay, yeah. Oh, okay, I see. Okay, I see. Okay.
And then you can assume that we'll always have non-negative n and s.
Okay, okay. And it's the same case actually for the s. If it's equals 5, just return 1. That's the corner cases. Then first we just populate the first the case when n equals 1. So I in range okay, I need to put some description here. So the row means how many jumps, and column means the column index, means the number we are at. Jumps. We just populated the first one. So first one for I, so equals, I think it equals jump dictionary I. It's the length of jump dictionary. So that means with only one jump, so where we can, oh, sorry, I think where we can, yeah, that's where we can reach. Okay. And yeah, let me see. So for the how reducing, because I'm still on track, or I think anything I need to pay attention.
I really can't disclose that at this point.
Okay. Yeah.
Do you need help, or do you have any questions?
Yeah, I was a little bit I just had some like thoughts. I'm not sure if it should be I just have a little bit like confused. It should be I should put the next step or previous step in the hash map, or they are actually actually they are same. So actually they are same. Okay. Let me see if are they same. Yeah, that's fine. Yeah, I just put it like this. Okay. Okay, I'll keep coding. Okay. I'll simply add the return jumps. So Harry, I finished the implementation. Can I try run some example with you? Or
Absolutely, yes.
yeah. And so let's say for the first example, when s equals 6, n equals 1. So s equals 6, n equals 1. So s is I'm not sure where I can write that. Okay, I can just write here. So s equals 6, n equals 1. Then we initialize we initialize a jump array. It's like the 1, and so the width is 10 and the height is 2. And for the row, for the jumps 1, so the element will be the how I populated. So it will be 2, 2, 2, 2, 3, 0, 3, 0, 3, 2, 2. And so since I think so since this range will give like no value, so immediately, okay, I see there's one bug here, so we need to actually to output this one. Yes, so eventually we will output 6, so it will be the okay. I think I miss. Okay, miss. Okay, another bug here. I miss the 7, so 7 will be the 1 or 6. No, 7 will be 2 or 6. 2. So the output will be jumps minus 1 and 6. So it will be the 3. So it's right. And if we use equals 2, then jumps 1 is already populated. For the jumps 2, so because we're 6, so we add so initially it's all 0. Okay. So it equals, so we just use it's key to search the jump dictionary. So we have the 0, 1, 7. Basically, we need to add the 0 and 0, 1, and 7. So 0 is 2, and 1 is 2, 7 also 2. So this will give 6. So this will, the output will be 6. So that's my dry run. So looks like my dry run, at least from these 2 examples, it agrees with the result.
So was that a question for me?
Oh, no, not a question. So I just say from dry run, I think it agrees with the examples you give me, the number. Okay. Yeah.
And what's the time complexity?
The time complexity is yeah, I think time is ON.
Okay. And what is the space complexity?
Space time complexity is still ON. So, but actually, I can further optimize to N01 if it's necessary.
How so?
A second.
Like how would you make it
I just add a mod to the. So when I initialize, I will only initialize like I first just sorry. I cannot just comment it. I will just use this just initialize like 10 multiplied by 2, this array. So for all the places I use use a row key, I just use a mod 2. Then basically we only can like it's a rolling like rows. It's like 2.
Okay.
Yeah, that's yeah, because that's how I'm gonna kind of like.
Okay. Do you want to?
But this one actually I can if it's no longer the 2 row. Yeah.
Okay. Do you want to run this function?
Okay. So, but run this function, just use you want to use space O1 or space not O1?
Run the function you currently have.
Okay, but kind of I need to change this one. Okay. This will be the N2. Okay. Let's see if it still makes sense. Can I go like let's check? Okay. Sorry. Okay. Oh, I'm missing one comma here. Well, parsing. Let me see where I made a mistake. Oh. Looks like I have some error somewhere. Expect, probably I need a, oh, shit. Okay, 3, so that's I need to comment this out. Okay, so that's the first, for the 6-1, it's 3. Okay, and for the 6-2, it's what? 6? Okay, do you want me to test more examples?
Okay, sure.
But I don't know the answer, so even I test more examples, I'm not sure if the just test.
You try with s equals 5.
Okay, s equals 5.
Yeah.
Okay. It will return 0 because at the beginning I just specified the corner cases.
Okay. Cool. And now, do you want to try the any other inputs that you want to test?
Okay. Because for any other inputs, just I don't know like what's the right answer. So I'm not sure if the answer is right or not. So that's
okay. What about like inputs that you know the answer to that you want to test?
okay. Yeah, the input I want to answer. Okay, I know the answer to is the only thing is n equals 1. Then I can try different numbers, so like not 5, like 7, 2, and Yeah, let me try start from 6. If we start from yeah, I just test like several, like just to try to see if it's making sense. So if we start from 0 with n equals 2, so let's see. Should equals. Okay, yeah, that's all I have. Yeah, I just tested one case, 0 with like n equals 2. Then I tried it should equals like for S4 N1 and the sum of S4 N1 and the S6 N1. Yeah.
Okay.
Yeah.
Cool. This is a this is a follow-up question that you don't need to answer. You can just think about it. So we see here that the DP solution runs in linear time. Is there any way we can do better?
Is there any way we can do better? DP solution run in time. Yeah, let's see. So yeah, I couldn't think of any way I can do better. I mean, I'm confident in, but I have some thoughts, but I'm not sure about those thoughts are right or not. So for now, I think that's the fast way. And I have other thoughts. Without verifying, I don't want to just rush or jump to any guess.
Okay, that's all right. Well, if you want to look more into it, I would suggest looking into this thing called Markov chains, which is a very high level concept, and you don't really need to look into it.
Oh, okay, Markov chain. Yeah, I think I heard. I remember I probably learned that before, but I forgot. Yeah, this guy's name is very familiar with.
Okay.
Yeah,
Yeah.
Markov
Just looking
chain.
into Markov chains, and then also the linear algebra, so the NumPy library as well.
Oh, NumPy. Okay, NumPy. Okay,
Very helpful.
okay.
So we're a little bit early on time, so let's just move into the debrief here. In terms of the difficulty for this problem, what do you think?
This difficulty for problem, I think it's kind of medium. I think it's kind of medium, so it's not too difficult, but it requires some thinking processes.
Okay.
Yeah.
What did you have to think about, or what was the hardest part to think about?
The hardest part is just under the pressure because it's kind of interview scenario environment. Yeah,
Okay.
because usually I need to think about some like brute force solutions first, and then go to the more advanced methods.
Okay. How many interview problems have you done in the past?
In the past, I think recently I done like 100 or something. So like for the last 1 month, I did around 100. Long time ago, I did like, but last year I did like maybe 200 something, but I already forgot them because I stopped practicing for 9 months, 10 months.
Okay, I see.
Yeah.
Well, you're in a good spot then. So essentially, this problem is you can find this problem here. I'm going to link it in the code bunk. So you are on this part of the page. Let me just put here.
Okay.
This is the where you can find the problem, and then also you can find the logarithmic time here.
Okay.
Essentially, what we wanted to do here is do dynamic programming, and so identifying the recurrence relation is pretty good. That's about it for this problem. In terms of getting the optimal dynamic programming, so like not having a 2D array, that's pretty good. And then also being able to determine the mapping for move dependent on your digit is also pretty good as well. In terms of Python, I would put jump dictionary in a global.
Okay.
In a global variable as a constant. And then also I can initialize all the values as 1 in the jumps array. That way I don't have to use the edge case corner case thing.
Yeah.
So just initialize it as 1, and then you should be fine. And the rest of it would be able to figure itself out.
Yeah. So one question here. So for the, because usually, I mean, what I was taught, like and never use like global, like a global variables or something. So you're saying basically in this kind of circumstance, if it's a constant, we'd better do it as a global constant. Is that what you? Okay.
Yeah, global variables or constant should always be global variables. I don't know.
Okay. Okay. Yeah. So do you mind I write down? So
sure.
Use define constant as a global variable, and the second thing probably initial jump dictionary. No, not jump. The jumps array with 1 to avoid the coding of edge cases. Okay. Yeah.
Okay. Cool. Then for the problem, in terms of comprehending the problem and then communicating that you comprehended the problem, that was fine. I would like you to make some corner cases and also define the jumping mechanism before starting the dynamic programming approach. So for example, you know that the 5 will never have a move set. Then you can also determine that having 5 as that you'll never reach 5 from any of the points.
Yes.
So what you could do for when you have 5 is run an early escape. That part can be communicated as well.
Okay. Communicate the edge cases before implementation. Is that the okay?
Yep, and also have more confidence about your time complexity.
Okay. You have more like how much confidence with that? What can you elaborate that?
Yeah, because you weren't sure about whether or not it was exponential for the naive solution.
Oh, okay, yeah.
Like, you know what the time complexity is, but you weren't confident about it. So that's what was a concern.
Okay, okay.
We don't know whether or not you got it because you were lucky or because you actually understand time complexity.
But I just worried, like in some cases, if I say too confidently with some wrong answer, could that be worse? Or?
It'd be about the same as if you weren't confident about the right answer.
Okay. Yeah, I see. Yeah.
That's about it from my side. Do you have any questions for me?
So earlier you mentioned one like 40 questions, like at here. I think I wasn't quite get that. You said a 40. That was a 40 questions.
Fourth question?
Probably I'm not sure I heard it clear. 40 questions or a false question. Because you asked me, do you have more examples? Then
yeah. Typically make up some of your own test cases and then run through them to see whether or not you have completely
then you said it,
all edge cases.
Then you said it was false question. You actually I didn't have to answer that. Is that?
The how to do better than linear time.
Oh, okay. So basically, okay. So it's
yeah. That's not a fourth question. This was just one question here. We and you don't have to provide the answer to it. Basically, I would look into Markov chains.
Okay.
To see how to get that part, and then also look into NumPy for the modules that would help you answer that problem in logarithmic time.
Okay. So how do you call those kind of questions? It's called just
there's a question bank.
Okay. Yeah. Okay. So basically, I don't need to answer. Okay. Yeah. Some question I don't need to Markov chain, NumPy modules. Okay. Yeah. Okay. I see. Okay.
Any other questions?
Yeah, no more questions. I think that's all my. So is the speed okay? Is the speed of like solving and implementation? Because I only solved like one problem, like within 40, I think less than 40 minutes. I saw around 40 minutes. So
yeah,
it's
speed's fine. You don't. There's no bound for this question. The speed is fine. There's no bound in terms of like what speed, like how quickly you need to do the problems.
Okay. So this problem is treated as what? As what kind of difficulty? It's like medium or hard? From
medium.
Medium. Okay. Yeah. Perspective. Okay.
The first part would be like recursion, which is like if you're entry level, then you can figure that one out. And then also dynamic programming if there's time remaining. But jumping straight into dynamic programming is fun as well. That's what would make this problem 2 problems.
Okay. Yeah, I think that's all my question for today. Yeah, thank you.
Okay, I'll let you go then. Good job today. And best of luck. Enjoy the rest of your weekend.
Okay, thank you. You have a good weekend. Bye-bye.